we are ready to move on to the next bivariate combination, two quantitative variables. In this video, I'm going to show you how to graphically study a relationship among two quantitative variables. Let's begin by looking at the steps for conducting a graphical and descriptive analysis of these types of relationships. We'll be learning more about each step in the next few videos. First, we graphically illustrate the relationship with a scatterplot. Next, we calculate statistics that measure the strength of this relationship. Finally, we model the relationship of a response variable to an explanatory variable with a formal model. For now, let's learn how to use scatterplots for graphical analysis. In a scatterplot, each point represents two measures for two variables on the same unit. Here's an example of a scatterplot. The two variables are located on the horizontal and vertical axes. When there is a clear explanatory variable, we put it on the horizontal or x-axis. The response variable is placed on the vertical or y-axis. In this example, we are looking at the displacement of a car engine. Displacement refers to how much volume the engine pistons push through to generate power. The response variable is horsepower, which is a measure of the car's power. This scatterplot will help us know if an increase in the displacement of an engine is associated with changes in horsepower. Every point in a scatterplot represents a unit of analysis. In this case, each point represents an automobile. The point is placed on the scatterplot based upon the measurement of the two variables. For example, this automobile has an engine with a displacement of about 275 cubic inches. It also has a horsepower of around 180 HP. The location of this point on the plot tells us the measures of these two variables for this automobile. When a relationship among two variables is present, the points will illustrate a pattern of moving up or down vertically when we move left to right horizontally. For the variables engine displacement and horsepower, there is indeed a relationship. As we move to larger and larger values of displacement, the points are higher up vertically, indicating larger horsepower. When the pattern we detect is vertical movement upward as we move from left to right, that represents a positive relationship. In this scatterplot, we can detect a definite positive relationship of engine displacement and horsepower. If we put more pistons in the car or bigger pistons with larger cylinders for them to push through, then the car will have more power. When the pattern is vertical movement down from left to right, that represents a negative relationship. Here's an example of a negative relationship. Notice the movement of the points in the vertical direction as we move horizontally from left to right. Obtaining larger displacement values yields lower gas mileage values. The larger the displacement in the engine, the lower the gas mileage of the car. Putting it all together, engine displacement is positively associated with power and negatively associated with gas mileage. This makes sense to me. If I get a bigger engine, the car will have more power, but I had better be prepared to buy more gas. The study of quantitative relationships is an important skill for analyzing research data. The creation of a scatterplot is a great first step. Now we need to learn how to use R to create scatterplots, and then we'll move to additional steps for studying bivariate quantitative relationships.